furniture. So AI in the cloud, this is our theme today. And we've had a long conversation about this beforehand, and all of us have slightly different views on what we think this is going to lead us towards talking about. But I think it's coherent. I hope you'll agree. Broadly speaking, of course, both are huge areas of investment right now. I checked out a few numbers online. I don't know how trustworthy they are, but global AI market worth about $60 billion by 2020 was one projection, so it's almost there now. We're getting very close. Public cloud industry worth about $200 billion right now, both of which will be growing by multiples in the next 5 to 10 years. And it is, so it's a huge, gigantic area, and the extent to which the cloud, of course, is where AI is and should be, is, I think, going to be part of our conversation. But first of all, I'd like to introduce Elena Eneva. She is a research scientist in artificial intelligence at Accenture. And Elena, would you just kick us off by saying where we're at now, just in practical terms for ordinary people, ordinary small to medium-sized enterprises perhaps, where is AI, where is it taking us right now in practical terms?
Well, it's taking us everywhere. Yeah. Right, so it's the new thing where it's, in one sense, it's the buzzword that everybody wants to be doing AI, and everybody is doing AI, right? But also, that's the future, right? Because AI is kind of a, what is it? It's math, it's statistics, it's pattern recognition, it's everything underneath, right? It's machine learning, it's in a broader sense, AGI, right? But the interesting part, I think, for this panel, right, AI and the cloud, is now where we're going is there's a new tool, right, that's available on the cloud to everybody, right? And those are tools, those are AI enabling tools. So how is that different? What can we do now that we couldn't do before? So the cloud has been around for a while, AI has been around for a while, but now that it's so easy for, well, not so easy, now that it's easier to do it on the cloud, it's sort of a game changer, right? On all the levels that you can think of, right? Big companies, great, huge amounts of data, they have access to the corresponding needed amount of compute, and they make the AI magic happen. Medium, small companies, right? The barrier to entry would have been much greater in the past, so this is something that fuels innovation, where a small startup can immediately try out an idea without having to buy huge amount of compute on their own and invest in having a team of AI researchers. And also the other layer is education, which, how many people here have taken Udacity classes, right? Or any other distributed courses, and how many of them have been around machine learning and AI? That's kind of a big boom. Lots of people are doing it. And the only reason why this is working out so well is because students have access to these cutting edge compute capabilities and AI capabilities, and they're learning. So this is something new that's building the foundation of what's going to be the future, right? These are the folks that will be creating the next wave of AI, or the next application, the next big thing. So this access, this universal access to insights now is very significant.
Steve Coy, I want to bring you in. Amazon, Google, Microsoft, they are the main players right now with kind of cloud-based AI tools, right? And there are kind of an arms race going on between them.
In the West, of course.
In the West, yeah. I'm not talking about China and other places where they will be rival stuff going on, of course. Is there a fallacy here that there's going to be, that we're all looking to the cloud, that the cloud is somehow where it's at, and that actually that is not genuinely perhaps where the focus should be?
I think it's an accurate statement about what we're doing right now, but I think that's a reflection of the fact that we're used to thinking about the internet. It's almost the same picture we had with the old mainframe and a bunch of terminals. the cloud is some nebulous place off, as the mainframe was before, where all the work gets done, and we're dealing with smaller peripherals. But that is because we're thinking about moving data from place to place. What's happening, the other major technological revolution which is happening right now is we are moving from the internet to the Internet of Things, and people are talking about trillions of sensors, trillions of actuators, all networked. The amount of data that we're dealing with and that will be feeding into these AI processes is going to be vastly greater. Some of it very high bandwidth. You need to make rapid decisions on different. So I suspect what's going to happen is as we move to the Internet of Things, we're going to shift from something where we think of sort of like one or more brains doing everything, to a hierarchical architecture where some things are done very locally, individual devices, swarms, cities, and hierarchically all the way up to the giant server farms like we have now, depending upon the scope of the data.
So microclouds.
But again, hierarchically, they talk to one another, and they talk at the scope that they need to. So when you're doing something over here and you need something over there, there has to be some coordination, but you don't need all of that information.
Murray, Cantor, I'll just bring you in because I know you're working with Mark and others on AI application. But just tell me a little bit about where you see this going, how you see the future. Because I mean, this is to do with bandwidth, right? There's an architectural problem perhaps about the cloud in terms of the speed of AI and the complexity that we're going to start seeing rapidly in coming years.
Okay, yes, I will do that. But first I want to reinforce something that Elena said, which is, at a previous panel I talked about a model that we're looking at, which is sort of the next generation model for local prediction of hydrological flow. And it's exactly because of the infrastructure you talked about that a small group like us can attack that kind of problem. And it's the software assets that are available, the hardware assets that are available, and all that. So here's a small, little, scrappy startup looking at a problem that the big weather systems guys can't solve just because of what you were saying. So thank you for that. To answer your question, I think I want to build on what Steve said. Here's an example. We're all looking at autonomous cars. Okay, now there's a lot of AI in those cars. Okay, all sort of, they're a thing, but they're connected via cellular networks and stuff to bigger systems. Sooner than later, they're going to start talking to each other. Because the way collision avoidance really should work is one car detects the other car's there, and they coordinate who's going to stop. Okay, and that's not going to go up through the brain. That's going to go through some sort of local interaction. And by the way, that's very much like how bodies work. When you react to a burn, it goes right to the sensors go right through the spine, right back to the muscles. They don't necessarily go through the brain.
So right now with autonomous vehicles, it is a cloud-based form of AI primarily, right? I mean,
well, not really. The autonomous vehicles are sort of autonomous.
Yeah, right.
But they're
learning. Okay.
They're going to become more, but they're going to turn into a swarm.
Yeah, yeah.
Just like what Steve was talking about. And so now what we're going to have is a kinds of intelligence. So now we have to look at the swarm intelligence of the swarm. This now gets us into how we're going to manage the AI that's going to live in that kind of environment. And the auto companies are going to come up fairly soon, I think, with messaging standards to create the swarm of vehicles. Okay. Now, the overall infrastructure that's going to make all this really work is the kind of thing Steve's talking about. Right? So you look at and the thing is that you look at the kind of tools that you were mentioning, all that's going to come together to yet another generation of things. And we're going to start getting to a point when that happens that we're going to have more than the sort of deep learning, doing a few things, to much more the general AI of the future is going to look more like this. And so it's an exciting time.
It's an exciting
And
time.
very good time for mathematicians, by the way.
Yeah. And an amazing time as well
Yeah.
for people building data centers, right, David? I mean,
Yeah.
we are seeing, obviously, the computing power having to rise exponentially.
Yes, the cloud is growing, and it's the central cloud, what we usually think of as the cloud. But in the cloud industry, the hot topic of the day is expansion to the edge. So small data centers, small deployments will be located in many, many, many more locations than regular data centers are now. And that's will really just be an extension of the cloud. It'll really just make the centralized cloud bigger than it is now, and basically everything's growing.
And the infrastructure there, I mean, what is the, I don't know, this is a open question to any of you, but what's the bottleneck on this expansion?
Well, the bottleneck on this expansion, just like on really any machines, is one of the bottlenecks anyway, is the removal of heat from those things. These guys, all the AI people are making heat, and then there are a few of us that are in the let's get the heat out business. So force physics is a technology that is going to make the edge deployments a lot simpler and more energy efficient, and then also the centralized ones for the same reason. So we're excited about the growth of the edge and the growth of AI. You know, the more value there is there, the more economic value our company has.
Elena, is bandwidth another bottleneck?
Yeah, the answer is yes, of course. Which I think is why it's so, important to realize that the future is not just one of, right? The future is this combination of on the edge, of full cloud, small data centers, distributed, as you were saying, right? So that you can address the specific problem, right? And you can have the compute as needed immediately, as the comparison you were making with the burn, right? When you need to make very quick, maybe simpler decisions. And then you can have the big brain computing when you have more bandwidth, right? When you have the ability in the background, looking at the big patterns, looking at the huge data, right? So you will have layers, you will have components, and because bandwidth is a problem, and it always will be, right? Because the more bandwidth we get, the more we're going to want to do with it. You just have to find a good system. You have to create a good system that combines things in a way that works.
Many greater minds than mine are in there in the audience, I know. So if you want to step up to the microphone at any point, please feel free to do so. Just one more question, Steve. We're talking, Murray, I think, was referring to the idea of what inevitably AI will lead us towards more devolved systems and so on. Is there also a kind of need for, is there an issue around control here, around who is in charge or who is in control of this system, of this evolution right now? Is there a fear around the big beasts of the tech industry being too in charge individually?
Well, so far we've mostly focused on the West, but look at the example of China.
Yeah, sure.
That is positively frightening, what they're doing with the social credit and lumping it all together. So that sort of model would worry me a whole lot more.
Is there an arms race between the US and China over this?
The thing is, with China, because it's a totally different sort of system, at least so far we haven't gone too far in that direction, we don't want to do what they are doing in terms of the use of AI and how it's deployed. What they're doing is tremendously powerful if what you want to do is control your society.
We're talking facial recognition,
social credit.
Yeah.
Yeah, all this stuff is linked together. So yes, there is an arms race in terms of the technology, that's part of it, but it also has to do with our different social models of how we want to use it. The other thing I wanted to comment on in connection with the distributed thing, there's a notion that has sometimes been described as a self-aware internet or Internet of Things. And I really think that is the model that we start going towards, because the natural architecture, if you don't just think of it about how is it that we will distribute a computational workload among a bunch of centers, but you say instead, Well, the actual things which are generating the data and acting upon it are network devices. They will be communicating with another, and they will, in an ad hoc sort of fashion, dictate who's talking to what, and then we will wind up needing centers like at city levels, because that's where we got lots of these things interacting. And I think this will be a natural self-organizing principle which will lead to architectures very similar to the way the human neurocortex is organized and talks to both the motor and sensor neurons. So that the things out there will be our muscles and our eyes and nerves, and all of the rest of what we now think of as being the cloud will be the nervous system.
Question?
Yes, so and I think this is to Murray, but the whole panel, that I think you're painting the future of computing a little too rosy. I mean, Dennard's scaling ended in 2005. You said heat is a problem, but isn't energy a problem as well? And that extends all the way to the edge. We don't have any magic coming out of the semiconductor industry anymore.
Well, this is actually more for you, but you're absolutely right that heat and energy, right? Heat is wasted energy, and if you can and if you also spend more energy removing heat, it just even gets worse. So the economics of the business is all about using less power, and generating less heat. And what's really cool about the stuff you guys are doing is that there are ways to do this by being much more clever about things like the aerodynamics of how we cool things. And now what I think is happening in terms of the bigger picture is that we are actually, the case for that kind of solution is now here. That what we're really discovering that these big data centers are tremendous heat sinks, energy sinks and heat generators.
Yeah.
Right.
And the way we can and so now it's time to invest in the efficiency of removing that. And technologies like yours are helping that. So, and I don't know if I'm being rosy, I just see it happening.
Well, it isn't just removing the heat, right?
Yeah.
It's in terms of not generating the heat in the first place by making the computation far more efficient. And we lost those scales of efficiencies over almost 15 years ago.
Well-
Anytime you do compute, there's a flow of electrons. Mark likes to talk about flows and interactions. There's always a flow. And whenever there's a flow, heat is generated from it. It's not a question of the efficiency of the computers, because whatever amount of computational performance there is, there will always be consumed. But you have to, in order to support it with the best economics, both financial and environmental economics, absolutely you want to minimize the amount of energy that's required to do it. So you're right on target.
Flow means friction.
Yeah, and actually maybe.
Sorry, one second.
One more thought to this, whether we're being too rosy or not. I think that in my mind, we're working on these two problems in parallel, right? How to have better algorithms, how to have better AI, and how to have more reasonable compute infrastructure, how to remove heat, where do we get the power from. So it's not that we've hit a bottleneck in one and we have to stop the other one and it's a problem, right? It's sort of, we know that we need to be working on both. And I think the advances are happening on both sides, sort of in a way that they're catching up with each other. So I think we're approaching it reasonably.
I'm sorry. I was just going to say, by the way, I'm often accused of being too optimistic. But another thought along the same lines is this idea that we're going to distribute the processing more widely with things that are, I also think it's just inevitable, but that's going to affect the energy economics of what we're doing. I haven't even thought.
Is distribution more or less efficient than centralization?
I think so.
More efficient.
Yeah, in terms of things like heat concentration and stuff. Yeah.
And if it reflects what you actually need to do. And like in AI,
There you go.
the big, the big usage of energy is the learning curve, not the usage. I mean, training neural nets and so forth. That's your. The thing is, we can reuse these things a lot, and that's part of the benefit of the scalability. So in the smaller nodes, we might not need to do so much.
But also,
Sorry, can we just
one quick thought on that, which is the point that is, if you can move the data only between where it needs to go and not up through a big center and back, there's an efficiency.
Yeah.
Right.
less journey time,
Yeah.
more efficient?
And less latency and all that.
Sorry.
I just wanted to make the point that we're getting AI offload hardware that is very well concentrated in the cloud, like FPGAs and GPUs, and a whole new generation of specifically designed co-processing for doing the training and also for doing the inferencing. And we're starting to see an interesting division of higher precision inferencing and the original training in the cloud, and then distributing the models out to the edge in containers for IoT where the data is. And it's not going to be a difference between concentrated in the cloud and distributed. It's going to be concentrated in the cloud for development of these systems and then use of it at the edge, because it's much more efficient to split it that
False
way.
dichotomies. I mean,
That's exactly your point, Steve.
Yes. Yes.
And the specific hardware that we're developing for AI is specifically aimed at dealing with things like Dennard scaling and doing it with FPGAs and making it much more specific to the workload that you're running.
right, which goes to that idea of a natural evolution, Elena. You agree with that?
Yeah, absolutely.
I don't know
my
if you're
mic on?
quiet again.
Okay.
Yeah.
Yeah, absolutely, and that's something that sort of a layer in the solutions that we're designing that we have to think about. And what you're saying about the specific hardware, that's sort of a point that I was thinking about when we're talking about democratizing access to insights, right? Where now suddenly people have access to these latest and greatest chips as hardware that's specifically designed for deep learning, right, or whatnot, where it's not something that without a lot of clout, without a lot of history, without a lot of funding, you would be able to get into. So again, lots of innovation due to that as well.
Murray.
Yeah, I'm going to take a slightly different view. Someone should sometimes.
Yeah.
And all that's true, but I don't think it's going to stay that way. I think there's going to be more learning going on the edge over time. And we're going to have more efficient, specific kinds of learning. So the thing is that I gave the example of the cars interacting with each other. We're going to have other kinds of sort of swarm behaviors involving heat management that is going to be much more sensitive across a building or something, right? And these things are going to have to learn to some extent from their environment, just like my Nest thermostat theoretically is learning something. So the idea is the cloud is where the learning occurs and the edge is where the inference is applied. I think is overdrawn. There's going to be some, over time, we're going to come to some sort of optimal solution or suboptimal solution, some economically sensible solution of the distribution of both.
So it's going to be semi-devolved
Yeah,
on the whole.
yeah.
And
Which I think it's more reason.
we talk about Internet of Things, and surely every time you talk about that, as a journalist, I'm not allowed to talk about that without talking about security. And I don't quite know where AI fits into that conversation, but if you have anything interesting to say, please say it now. Because I think a lot of people are scared, aren't they, about that kind of devolved power around you.
Yeah.
And I mean, where does AI play a role in that?
Well, AI raises the stakes, but my personal view is that is not really the key in terms of security. We just had a panel talking about blockchain type things, and that has more of the flavor of what I think is needed to maintain a verifiable chain of authority. I mean, ultimately, it's whoever owns the topmost device. I mean, so we're following ownership. There is a notion called verifiable claims, which can be used in a whole variety of ways, but one of which is, I have the authority to tell you to do something to a device. So I think that there's lots of interesting thought, but I think it's more like AI means you care more about whether you can tell it, who can tell it what to do.
Murray.
So I have a quick thought on that since we're running out of time. Here's your nightmare scenario. Somebody figures out how to upset the car's AI so that it outrates them all to hit each other.
Yeah.
This could be, I mean, this is not all, I mean, the kind of thing that goes on in the intelligence community, we're always worried about the false insertion of messages. Mm-hmm. And so there is, I mean, that's a security issue.
But
right?
the more devolved the AI, the safer, presumably, would be your argument. No?
I don't know.
If it just takes one crazy car, and then...
Well,
Yeah.
but yeah.
Human
And
intelligence
on
is
the other
pretty
hand-
well evolved, and I don't know how much safer it's gotten.
That's an interesting point. You know, can we make the cars more sane than the people? That would be good enough, right?
Yeah. So,
Sorry, go on.
I've done a lot of work in IoT, and my favorite saying about it is that the S in IoT stands for security, which is something you've probably heard before. But I think the problem is not with IoT. In general, it's not an inherent problem of they're lacking security, right? The problem is with how we've defined this, right? And the devices that we're using and the cost that we're okay with, right? And what we count on and how we sort of understand our trade-offs, right? So we can deal with the security issues. In IoT, just the problem has to be structured differently, the devices have to be different, we have to be a lot more strict about the potential holes and so on, right? But how AI could help is, in general, in fraud detection and in security breach, we'll talk about cybersecurity later today again. You're looking for patterns, right? And what AI does is it can find the big patterns that are hard to fake, right, or impossible to fake. And it's perhaps another tool to find a malicious attempt, right, that's happening, or to find the beginning of a trend that will be bad, right, or to find some other patterns that are somehow indicative and helping with preventing security issues.
On which optimistic note,
I
we
like
will
that.
have to leave it. We're going to have to leave it because we have overrun. I'm a bad boy. I'll let you keep talking. Thank you very much.